A great thing about working with text files is that you can easily find and see the differences between two files. In this unit, we'll see how we can create such a list of differences, how we can interpret this list, how we can adjust it, and how we can process the results of the set of differences. Finding the differences between two files and listing them isn't trivial when you want to show a minimal set of differences. However, it's remarkably useful. Let's see how we can use the UNIX diff command in order to do this.
For example, consider the following two files, file1 and file2. They are different. In the second file, there is no start line, the E is uppercase, and the word AND is followed by the word MORE. If I run diff with file1 and file2 as an argument, we get the list of differences between the two files. The output contains the changes going from the beginning to the end. There is one line deleted, one line changed, and one line added. The line deleted on the first line is the start line missing from the second file. Then, on the sixth line of the old file, the lowercase e goes out and the uppercase e comes in. This corresponds to line 5 of the new file. Finally, the MORE line is appended on the file's 8th line.
The diff command provides many options for adjusting the format of its output.
The context format is a commonly used diff option and format. We obtain it with the -c option. Here we see both files with the changes between them. In the first file, we remove the start line and change the E. In the second file, we change the E and we add the MORE line. The addition is shown with a plus, the removal with a minus, and the change with an exclamation mark. Another format is the unified context one. We specify it with the -u option. It shows the differences between the two files together. Here, we can see that the changes are shown again with a minus and a plus. The lines removed are shown with a minus, the lines added are shown with a plus, and the changed lines with a combination of the two. Another format allows us to see the differences structured in columns. We specify the -w option, the number of characters per column, and with the -y option, the format's type. The changes are indicated with a vertical bar character, the removals are shown with a less than sign, and the additions are shown with a greater than sign.
One option that we can pass to diff allows us to obtain the differences in a format that we can then feed into the ed editor. Using these differences, the ed editor will then transform the contents of the first file to match the second one. This is the basis of the patch command.
Here I run diff with the -e option to generate an ed script. I saved the output to a file named diff. If we look into the diff file, it contains ed commands such as on line 8 append line MORE, change line 6 into an uppercase E, delete the first line. We can concatenate the file diffs with the output of the command echo w, which sends to the ed a write command. Then we feed it to ed. The minus specifies that it will take the command from the standard input. We apply the script on file 1. As we can see with the diff command, there aren't any differences between file 1 and file 2. The two files are the same, as ed has applied the changes on file 1 and made it the same as file 2.
Modern patching uses a tailor-made program called Patch, which is more robust than using ed for this purpose.
Consider John and Mary working together. Mary has a program that prints Hello World. John takes the same file and corrects the function declaration. He adds void in the function main and int as the return type. Then Mary notices a typo. She adds the missing R in the word world to make it world. She generates the context diff with the diff -u command and generates the patch file. John can get the patch file and apply it on his file, even though his file is different now from Mary's file. He runs patch on the file john.c, taking as input the file mary.patch. We can see that the patch program shows that Hank 1 succeeded with a fuzz of 2. There is an offset of 1 line. Still, Mary's change made it into the file. We see here the final version of John's file. It includes the correct declaration and world is spelled correctly.
Often, files are different in very trivial ways. In such cases, we might want to ignore the differences.
Here are two examples of options we can use. Consider this file written by John. Mary introduces some changes. She adds spaces around void in the main definition, changes the indentation from 1 tab into 4 spaces, and adds a return 0 statement. If we run diff between John's and Mary's versions, we see all the changes, including the spaces around void and the change of indentation. These are not really informative. We would normally want to see the return 0 change, as this is the only material change. We can specify the -b option to ignore changes in the amount of white space. This ignores the blank at the beginning of the line. However, the -b option still shows us the changes in main related to the addition of new spacing. If we don't want to see any changes in the white spaces, we can specify the -w flag to diff. This gives us the return 0 as the only non-white space change.
In some cases, we don't want to compare files, but entire directory hierarchies.
Here is an example of recursive differencing. First, I create two deep directory hierarchies. They have the subdirectories A12 and B13. Into them I put a README file, one under A, one under B, one under A1, one under B1. All the README files are different. If I run diff on A and B, I get that the directories are common. Both A and B contain a subdirectory called 1, and that the README file in A differs from the README file in B. Note that the differences underneath directory 1 are not shown. We can use the -r option to diff to specify that this will be recursively applied to subdirectories. Here we see more results. We get that A1 contains 2 and B1 doesn't contain it. We also get the differences between the README files within the subdirectories 1 and 2.
The exit code of diff is useful for writing conditional statements.
To see this in practice, let's first create 3 files, file 1 and file 2 which are the same, and file 3 which differs from file 1 and file 2. If I run diff with the -q option on file 1 and file 2 which are the same, and add as a conjunction echo same, then, if the files are the same, we'll get as output the word same. The -q option means to do a quick diff. On the first difference, diff will exit with an exit code of failure, different from 0. Otherwise, if the files are the same, diff will exit with an exit code of success, 0. If I run the same command on file 1 and file 3, I don't get the answer same. We can also check if both files are the same or otherwise echo different. In this case, running the command on file 1 and file 2, we don't get anything as output. On the other hand, if I run the same check between file 1 and file 3, we get different as output. The echo different command is only executed when the files are different. Based on the exit code of diff, I can write a script that would make files the same only if they are different. First, I compare the two files. If they are the same, I echo files, first name and second name are the same, doing nothing. If they are different, I echo files, first file name and second name differ, copying first name onto second name, and then I copy the first file onto the second one. Now, if I run make same on file 1 and file 2, I get as output doing nothing, but if I run make same on file 1 and file 3, I get as output that they differ and that file 1 is copied onto file 3.
This concludes our unit on processing data by finding file differences. Stay with us.